Hello. Once again, same setup. So my webcam's up here, so if you see me looking down, it's because I'm looking down at the notebook. The 2.7, square roots and real numbers, and put today's date. This is our last section of Chapter 2. And it says, I can classify real numbers and graph inequalities on a number line. And go ahead and get our vocab for this section. Our very first vocabulary word is square root. And it says two of the same factors of a number. So the same means it has to be the same number and itself. So a number and itself. Remember back in our first lesson ever, factors? It's the two numbers that multiply together. So two numbers that multiply together to make it. So, for example, if I have the square root of 4, well, 4 is made up of 2 and 2, so our square root of 4 is 2. Okay, our next one is perfect square. And perfect squares is when a square root equals a rational number. So I'm just going to refer you back up here. 2 is a rational number, so square root of 4 is 2, is also a perfect square. It's when a square root equals a rational number. Our last one is rational approximation, and it is to approximate an irrational number to a close rational number. And basically, the big keyword here is the approximate, and that just tells us to estimate, so estimating numbers. Okay. Now, our examples. Example 1, remember to write what I have here in my marker, so example 1. And we're given a negative square root of 49 over 256. So, even though we see this negative symbol out here, we're just going to drop it down. So drop down our negative symbol, and our square root bar is over a fraction. So I break it apart and put it over just the numerator and just the denominator. So 256. If you want to make yourself a little note to square root is something you all can see either on a multiplication table or on your calculator. There's a couple of different ways you can find your square roots if you're not used to doing them on your own. Most calculators will have a x squared button. There we go. Like that one. And then, I know it's really hard to see, but right above it, there's a little square root bar. So if your calculator square root bar, you can use it. If it doesn't, you can use a multiplication table or whatever else you have. But a number in itself that makes 49 is 7. So I drop down my negative symbol again and say 7 over. And then once again, we need a number that can go in 256. And that is 16, and itself can go into 256 evenly. So number 1 is a negative 7 over 16. Our second example, we have a plus or a minus square root of 0.81. So once again, we're just going to drop down our sign, plus or minus. And what that means is that the answer could be positive or negative. And then square root of 0.81 is 0.9. Because if you see, if I ignore this first part and just say, what's the square root of 81? 9, and then just put my 0 in my decimal, that's another way to do it. So there's our examples 1 and 2. Now, you don't have to copy this down. This is already in your notes from lesson 2-1. Number, rational, integer, whole, natural, irrational. All we're going to do today is kind of review that. So if you want to, as we do these next couple of examples, look back to your 2-1 notes. That would probably be handy. So, example 3 gives us 5/22. Okay? And wants us to name the set the number belongs to. So it's always easier if we start with our smallest sets. So our smallest sets are natural numbers. That's counting. So I wouldn't usually count to 5/22. So I'm going to mark it out. Then we go to whole. Whole is your natural numbers plus 0. So it's not 0, so it's not whole. Integers are all your whole numbers and their opposites. And it's not negative, but it's not a whole number, so it's non-integer. So that leaves us with rational numbers, which is anything that can be written as a fraction, and it is. If you remember back from our notes, one max numbers was letter N, W, Q, equals R. So we're going to put Q for rational over here. And all the numbers we look at today and for the whole year are going to be real. So Q and R. Now, example 2, we're given the square root of 121. The very first thing we need to see is, can it reduce? Can I take the square root of 121? Yes, I can, and it gives us 11. Now, 11 is a number I can count to, and because I can count to 11, it makes it natural, which is also whole, an integer, rational, and real. So the smaller the group it's in all of them. So it's in all of these, natural, integer, rational, real. So if it's in the smallest one, it's going to be in all of those. Now our next one, our example 3, gives us the square root of 56. And once again, we need to see, can I take the square root of 56? So let's do that real fast. Square root of 56 gives us 0.7483, and it keeps on going, and it doesn't have a pattern, it doesn't repeat, and it doesn't end. So that makes it irrational. And all of our numbers, once again, are real. And our fourth and final example for this set, oh, I got off numbers, that's 3, 4, 5, this is example 6, that was my mistake, I'm sorry. So example 6 has -36/4. So because our top number is bigger than our smaller one, we need to see if we can simplify that. So remember that fraction bar tells us to divide. So -36 divided by 4 is a -9. And then once again, go back to your number subsets. Would I count -9 for my niece who's 4? Is it a natural number I would count for a little kid? No, so it's not natural. Whole is all your counting number in 0, so it's not 0, so it's not whole. Integers are all your whole numbers and their opposites. So 9's a whole number, and the opposite of positive 9 is -9. So it's an integer, which is z. It's rational and real. Okay, so that gets us through classifying our real numbers. Now this next portion is having us graph inequalities on a number line. Okay, and it shows a set of real numbers. And inequalities, if you remember from the beginning of the year, they are greater than or equal to, less than or equal to. So there's a couple of things we need to write down real fast. Sorry about that. So our very first one When it points to our x, it's making fun of him because he's smaller, so it's our less than. And less than is left. Alright, it's now eating the x, so x is bigger, so x is greater than. And greater than is to the right. Okay, our next one has a bar under it, which means equal to, so it's less than or equal to. Okay, and our last one is greater than or equal to. Now that equal to means we include the number. So if I have the little line under, that means I include it. So that's a equal to. Include. Now one thing I just want to point out is that if you look at the direction it points, this arrow points left and it shades left. This arrow points to the right, which means we're going to shade right. So shade, direction, the inequality points. So shade, the direction, it points. Okay, our next set talks about our circle. So if it is x is less than or greater than, it's an open circle. So the circle is open because we don't include. And then if it's equal to, less than or equal to, or greater than or equal to, the circle is closed. So for the top one, like circle, the bottom one, like we said, equal to means we include. Okay. This says to graph each solution set. Now for these number lines, they don't have to be anything too terribly fancy. I'm going to put 0 here, -1, -2. Alright. And so this is example 7 for us. And it has x is greater than -2. There we go. Finish up my number line here. So we look at our inequality symbol. First thing to do is to decide if it's an open or closed circle. So no line under it means it's open because we don't include -2. And then it says x is greater than, and it points to the right. So I'm going to shade to the right and shade in my arrow. All right, example number 8. Given a is less than or equal to 4.5. So if I have 0, 1, 2, 3, 4, 5, we have to first decide if it's an open or closed circle. So it underlined, so right there, that line under it means it's equal to, so it includes it. It's a closed circle at 4.5, and 4.5 is right between 4 and 5. Then the arrow points to the left because A is less than, and less than is left. L should always remind you. It rhymes. Okay. Now the next set just wants us to state the greater than or less than between these two numbers. So 8 we're given, example 9, my mistake. Example 9 we're given two numbers. Square root of 19, then we have a blank, 3.8, repeating. And I gave you a little bit of a hint up here that we get all numbers in decimal form. So that's going to help us out. So the square root of 19 gives us 4.35. And then this is already in decimal form, 3.8. So 4.35 is greater than 3.8, so it wants to eat the 4.35. And then that's our answer. Same way on example 10. It gives us 7.2 repeating. And we're then asked to find if it's greater than, less than or equal to, or greater than or equal to square root of 52. First step, get it all as a decimal. So the square root of 52 is 7.21. And if we look over here, our other one's already in decimal form, so 7.2 repeating. Now, that repeating symbol means that our next number after this 2 is going to be 2 again. So which one's going to be bigger, 7.22 or 7.21? Okay, and that makes our 7.22 just a little bit bigger, so it eats the 7.22, and there we go. That's example 10. Our very last example, once again when you get in decimal form. Example 11 gives us 2.63 repeating, negative square root of 7, 8 over 3, and 53 over negative 20. 53 over negative 20. And once again, we're dealing with different types of numbers. Let's get them all as decimal. The very first one's already in decimal form, 2.63 repeating. Our next one's a negative square root of 7. So once again, we drop down our negative symbol. And we say that's 2.646 because it rounds up. Our next one's 8 divided by 3. So we'll go ahead and do that one. We get 2.6 repeating. And the very last one, we get 53 divided by negative 20. And that gives us negative 2.65. And we're asked to arrange these in order from least to greatest. So we have to find our smallest number. I'm going to go ahead and warn you, you can't be deceived by the negative symbols, okay? So remember, I'm going to sketch out here, if you have your number line, the farther to the left it is, the less of a number. So the farther left it would be, the lesser it is. So from least to greatest. So which one of these would be my least? So if I look right here, my negative 2.646 and negative 2.65, this one would just be a little bit farther left because it's just a little bit smaller. Because it's a bigger negative means it's farther left, which means it's going to be my smallest. So this is number 1. It's my smallest one. And what I'm going to do is I'm going to write the original. So I'm going to write down 53 over negative 20. Then my only other one I have is my negative square root of 7. So once again, we're going to write in the original, which was negative square root of 7. Alright, then I have 2.63 repeating and 2.6, which means the number after this one's another 6. So which one of these would be my smaller number to put next? And it would be my 2.63 repeating. And my greatest one, and my original here, and it is my biggest number. So once again, just go through, double check yourself. That's 1. This is the second smallest, or third, which makes him, he's my largest number. Alright, and that gets us through this set of notes. 2.7's finished, so be prepared for note check tomorrow.